Welcome, ladies and gentlemen, to Unit 4, Part B, Quadratic Equations Graphing. We will be doing tons of graphing in this unit, so get ready. We are going to embark on a new mathematical journey. So here we go. Ladies and gentlemen, please don't write this down, alright? But we have graphed already this year lines. So linear equations, lines with shading, linear inequalities. We've graphed V-shaped, which is the absolute value function. And now today we're going to graph U-shapes. Alright, they're going to be very similar to our V-shapes, except they're going to be U's for unicorn. Alright, here we go. Quadratic equation in standard form. We need to have this whole page written down, alright? Y equals ax squared plus bx plus c. So if we think back about the last unit we just did, this is the quadratic equation. This is going to be in our standard form. These equations, the ones that look like this, are going to graph U-shapes, or what we call parabolas. Alright? So there are some key features to our parabolas. So if you want to draw a parabola in your notebook, please. It doesn't have to be exactly like this, but something very similar. We have some very important things. The vertex. The vertex is right here. This point. The point that changes, where it's going from down to up. It's the center of our parabola. Then we have x-intercepts. Okay, they're also called roots or zeros in this chapter a lot, but there are x-intercepts where it crosses the x-axis. So right here and right here. So those are our two x-intercepts. Then we also have axis of symmetry. Now this is a line that cuts our graph exactly in half. So what happens on one side of our graph, the other side is going to look exactly the same. So if we folded this in half, they would be right on top of each other. Alright, here we go. This needs to be written down. It's very, very, very important. In order to graph our parabola, the first thing we need to find is our vertex. How we find our vertex in this section is we're going to take the opposite of B over to A. So this right here, the opposite over B, is our x value, and it's also going to be our axis of symmetry. And the y is going to represent whether we're going to have a max or a min value, and it's also going to represent that value, where it's going to be at. Alright, first graphing example. We are going to graph this parabola. It's a parent function, and it's y equals x squared. So first thing we need to do is find our vertex. Now, if our standard form is y equals ax squared plus bx plus c, and to find our vertex, we would take negative b all over 2a. If we look at this one, to find our vertex, we don't have a b, so we're going to plug in 0 for b. So it's going to be 0 over 2, and our a is 1. If we take 0 divided by 2, we just get 0. So for our vertex, it's going to be 0 something. Our vertex is always going to go in the center of our table. So x value is 0. If I'm going to show my work here, I take 0 squared, which is just 0, so my y value is 0. Therefore, my vertex is 0, 0. Alright, once we know our vertex, we can do everything on our table and we can graph it, okay? Before we do that, I like to determine whether it opens up or if it opens down. Now, this is going to be the same as our absolute value ones. We're just going to look out in front. If it's a positive out here, it's going to open up. If it's a negative, it's going to open down. Since this is a positive x squared, this one is going to open up. Alright. Then, before we even fill out the rest of our table, we can determine our axis of symmetry. That's going to be x equals, remember that's our x value of our vertex, so it's just x equals 0. We can also determine whether it's going to be a max or a min. Okay, if it's going up, it's going to have a minimum. And our value is always going to be our y value, so y equals 0. Now we're also going to determine our domain and range and whether it is increasing and decreasing intervals. But before we get to those four, we're going to finish out our table and we're going to graph. So for our table, I'm going to do 2 higher than 0 and 2 lower than 0. So I'm going to use 1, 2, -1, -2. Plug this into work. 1 squared equals 1. So my y value equals 1. 2 squared equals 4. So my y value on this one's going to be 4. Come down here. Now, my x is all together. It has to be parenthesis -1 squared. If we type that into our calculator, we're going to equal 1. So my y value is 1. Here I'm going to have -2 squared, which is just going to give me, 4. So my y value is 4. Now that I have my table, I can graph it. So I'm going to start here, 0, 0. Then I have 1, 1, 2, 4. Then I have -1, 1. And then I have -2, 4. Now this is going to make my nice parabola, my U shape. So there's my U shape. Now, in order for me to be done, I need to do a few things. I need to label my vertex, which is 0, 0, and I need to put in my axis of symmetry. So x equals 0. So I'm going to have a dotted line right here through my vertex, and I need to label it x equals 0. So now that I've graphed it, now I can start thinking about my domain and range. Domain and range are going to be just like they were when we did absolute value. So my domain on this one is going to be x such that x equals all real numbers. Always, always, always going to be this for our parabolas, okay? Now my range is going to be my y values, so I'm going to have y such that y, now if we remember back to our absolute value, our y values is represented by our y and our vertex. If it's going up, then it's going to be greater than or equal to 0. Now, next thing we're going to talk about is increasing and decreasing intervals. This is a new concept for us. So when we look at our graph, I always start here and I picture myself. If I was standing on this graph, standing on the top right here, the thing I would do first is what? Go down. So I'm decreasing. So I'm going to go to my decreasing one. If I start on this side, this over here is -infinity. I'm always going to start over here at -infinity. So I'm decreasing from -infinity all the way. When I get down to this spot right here is when I'm going to stop and turn around, and that spot right here is 0. So I'm going to stop at 0, and I'm going to have a closed bracket because I'm actually touching 0. It's possible. And then once I get here at 0, I have to go up. So I am increasing from 0 all the way over here. I have positive infinity. So increasing from 0 all the way to positive infinity. All right, example number 1 done. Moving on to example number 2. We're going to do everything in the exact same order except for now we have a lot more in here. So first thing we have to do is find our vertex. In order for us to do that, we're going to take opposite of b, so -6 over 2 times a, which was -1. So -6 over -2, which is just 3. So my vertex here is going to be 3 something. So in my center, I'm going to put 3. Then if I would type this all in my calculator, the negative's on the outside, so parenthesis, 3 squared plus 6 times 3 minus 8. Now, if you can type this whole thing in your calculator just like this, as long as you use your parentheses, and then you'll find that you're going to get 1 for your y. So our vertex is 3, 1. Now, same as the last one, we can go through. Is this going to open up or down? If we look here, since this is negative, we're going to open down on this one. So we're going to have a u that's facing downward. We can also determine the axis of symmetry. Remember, that's just what x is here. So it's x equals 3. That's what our axis of symmetry is. We can determine if it's a min or a max. Now, since it's going down, we're going to have our highest point up high. So we're going to have a max. And the value is always my y value, so y equals 1. Now, before I can determine my domain and range in when I'm increasing and decreasing intervals, I need to fill out my table and make my graph. So here I'm going to go 2 above 3, 2 below 3, so 4, 5, 2, 1. Type these into my calculator, negative parenthesis 2 squared plus 6 times 2 minus 8, and I get 0. Negative parenthesis 1 squared plus 6 times 1 minus 8, and I'm going to get negative 3. If I put 4 in, I have negative parenthesis 4 squared plus 6 times 4 minus 8, and I'm going to get 0. Plug in 5, so negative parenthesis 5 squared plus 6 times 4 minus 8. And if I plug that in my calculator, I'm going to get negative 3. And if we notice, once again, just like our v's, these are going to be the same every time. All right? So now we're going to graph this. I have 3, 1. That's my vertex. And then I have 4, 0, 5, negative 3. Other side I have 2, 0, and 1, negative 3. So here's my parabola that is going downwards. My vertex here is 3, 1. I also, don't forget, we have to put in my axis of symmetry right here, what cuts my parabola in half. X equals 3. All right. Now, we can do our domain and range. Domain, every single time it's going to be exactly the same as x, such that x equals all real numbers. The range is going to be our y, such that y, now if it's going down, it has to be less than or equal to, and it's always, 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 you guys, the y value of our vertex, so it's just going to be 1. Now our increasing and decreasing variables. Always, always, always start here. So we're starting at negative infinity. Here I am on my graph. If I was going to start here, I'd have to go up. So I'm going to be increasing. So we'll start with increasing on this time. We're starting at negative infinity. And we're going all the way till we get to this point right here, which is our vertex at x equals 3. So all the way to 3. Once I get to 3, I have to go down, which means I'm decreasing all the way to positive infinity. So I'm going to go from 3 all the way to infinity. All right, moving on. Here we go. When the graph opens up, if a is greater than 0, which means we're going to have a minimum, and we can tell our minimum maximum value by our y value, of the vertex. Now, if the graph opens down, if a is less than 0, which means it's going to have a maximum point, and we can determine what that maximum is because of the y value of the vertex again. Now, just as a reminder, ladies and gentlemen, the vertex is the opposite of b over 2a. That's how we find it, and we plug it in to find our y value. And the key features, we have to have a vertex. We have to tell if the graph is opening up or down, the axis of symmetry, the max and min and the value, the domain and range, and the increasing and decreasing intervals. So that is all I have for you guys today. I hope you're having a wonderful day, and thank you so much for watching. Bye.